Well, folks, we've made it. In the final video of this unit, we will solve equations that resemble the format of those from video 1 in this lesson. Only now we have ax subtract b equals c, where a, b, and c are whole numbers. For the final time, to solve, we isolate the variable to determine its value. We get the variable by itself. We have now repeatedly witnessed the importance of recognizing that addition and subtraction are opposite operations, as are multiplication and division. As we now examine linear equations of the form ax subtract b equals c, where a, b, and c are whole numbers, we need to realize that we are again dealing with multiple operations. The ax is a multiplied by x, and minus b indicates the operation of subtraction. As before, in this scenario, we must deal with the b value before dealing with the a value. Our first example, 3x subtract 4 equals 5, and we are solving for our variable x. We're going to have a look at algebra tiles once again here to assist us in understanding the algebraic process. We're going to represent 3x subtract 4 equals 5. Left-hand side, we have our 3 variable tiles for 3x. We have our 4 negative unit tiles for subtract 4. And on the right-hand side, 5 positive unit tiles to represent the 5. Left-hand side, right-hand side. And left-hand side, right-hand side. If we recall the process we followed when using algebra tiles, we need to remember that we had to get rid of the 4 negative unit tiles in this case on the left-hand side first. But in this particular question, we cannot simply remove 4 negative unit tiles from both sides because we do not have any negative unit tiles on the right-hand side. How did we deal with this? We introduced the zero pair idea. So with algebra tiles, we introduced 4 positive unit tiles on the left, which meant that we had to introduce 4 positive unit tiles on the right. Symbolically, 3x subtract 4, I put in plus 4 for the idea of adding in those 4 positive unit tiles, equals 5, and because I introduced 4 positive unit tiles on the left-hand side, I have to introduce 4 positive tiles on the right-hand side, plus 4. Whatever you do to one side, you do to the other. So in the algebra tiles, this created the 4 zero pairs, which we could remove. Symbolically, that's the same thing as saying minus 4 plus 4 gives us nothing. So we're just left with 3x, 3 variable tiles. And on the right-hand side, if you count up those units, you will get a total of 9. 5 plus 4 equals 9. We have 3x equals 9. We have not yet isolated one variable tile, but we have strategically grouped what we have left so that it should be fairly obvious that one variable tile corresponds with 3 unit tiles. Symbolically, this is the idea of taking our 3x, which means 3 times x, and instead of multiplying by 3, we have to divide by 3. And what I do to one side, I do to the other. 3 divided by 3 gives us 1, so we just have 1x, and 9 divided by 3 is 3. As we see with our algebra tiles, x equals 3. Let's do a verification. 3x subtract 4, circle 5. In place of the x, we put the 3 that we found x to be. Subtract 4. Will the left-hand side equal the right-hand side? I certainly hope so. 3 times 3 is 9. 9 subtract 4, and yes, 9 subtract 4 is 5. 5 equals 5, so x equals 3 is our solution. Let's continue with solve for m. Our equation is -1 plus 4m equals 15. Just to point out, this is the same as 4m subtract 1 equals 15. As long as the sign or the operation in front of your term remains the same, you are good. My variable is on the left-hand side, so I must deal with this -1 or -1 part first. To get rid of a -1, well, if I had one red unit tile on my left-hand side and I wanted to get rid of it, I would add in a positive unit tile. Do the opposite. Instead of -1, we have +1, or instead of -1, we have add 1. 4m. If I added 1 on the left-hand side, I must add 1 on the right-hand side. -1 plus 1, that zero pair is gone. So we're left with 4m, and 15 plus 1 is 16. We have 4 times m. The opposite to multiplying by 4 is dividing by 4. And then I have to go 16 divided by 4. 4 divided by 4 just gives us the 1, so we have a 1m equals 16 divided by 4 is 4. Let's check our answer. -1 plus 4m, 15. In place of the m, we put our 4. -1 plus 4 times 4 is 16. -1 plus 16, yes, that is 15. M equals 4, correct. Solve for C, our variable. Where's it to this time? On the right-hand side. That's okay. If you want to do the flip-flop, that's up to you. You can attack the equation in that form as well. In the format that we've been given, my variable is on the right. I need to deal with the -17 first. That's our b value here is 17, so we have to deal with that first. The opposite of subtract 17 is add 17. And if I add 17 to the right-hand side, I must add 17 to the left. 23 and 17 will give us a 40. And -17 plus 17 is gone, and we're left with 8c. On the right-hand side, I have 8 times c. 8 multiplied by c. So I must divide both sides of my equation by 8. The right-hand side, that will leave me with 1c, and 40 divided by 8 is 5. So c equals 5. And a quick check. 23. 8c subtract 17. In place of the c, we have a 5. 23. 8 times 5 is 40. And yes, 40 subtract 17 is 23. C equals 5. We are good. And we wouldn't be completely finished if we didn't end off with a little word problem. 5 less than 2 times a number, p, is 29. Our task, write the linear equation to represent this mathematical sentence and solve it to find the value for p. 5 less than 2 times a number, p. We have to write down this idea first. 2 times a number, p, will be 2p. We need 5 less than that. 5 less than that would be subtract 5. The less than part, of course, indicates subtraction. Is, there's our equality sign, and on the right-hand side, we have a 29. Our linear equation then, 2p subtract 5 equals 29. We now need to solve. The variable is on the left-hand side. We need to deal with the -5 part first. Our b value here is 5. The opposite of subtracting 5 is to add 5. And what I do to the left-hand side, I must do to the right-hand side. So we have added 5 to both sides. That will get rid of the -5. We're left with 2p. 5 and 29 gives us 34. We now have 2p equals 34. 2 times p equals 34. The opposite of multiplying by 2 is to divide by 2. And dividing by 2 here isolates our p, our 1p, But if I divide the left-hand side by 2, I must divide the right-hand side by 2, and that will give me 17. P equals 17. The algebraic techniques that you've been introduced to in these last few videos, I cannot stress how important they are. You will use them throughout the remainder of your math courses, and they will help you solve so many different types of equations, not just linear equations. I sincerely hope you've established a solid foundation that will allow you to solve any type of equation in the future. And now I'd like you to proceed to the activities for Lesson 3.